All right, today we are going to be doing the code number 1481, which is least number of unique integers after k removals. So if we read the problem description right here, it says given an array of integers r and an integer k, find the least number of unique integers after removing exactly k elements. So if we see example number 1 right here, we have an array which consists of 5, 5, 4, and we are given a k of 1. So we are only allowed to take out one element from this array. So if we see here, we cannot take out 5 because there are two number 5s. So 5 occurs twice. However, 4 occurs 1 time. So we can't take out the number 4. So if we were to take out the number 4, we would see that we would have 5, 5 left in the array, which is just 5, which is just one unique integer in the array, so our output should be 1. Okay, so I'm gonna bring up paint just to illustrate the process of how we're gonna do this. So right here in our problem, so we had 5, 5. We review this, so we just take out the number 4, and we see that we have 5, which is just one integer, just one unique integer. So now let's look at example number 2. So we have 4, 3, 1, 1, 3, 3, 2. We have a k of 3. Our objective is to find the least number of unique integers. So for example, let's just say we wanted to take out the 3, which it is possible because we could take out 3 integers and 3 occurs 3 times, so it is possible. So let's just say if we were to take out the number 3, our result would be 3 because 3 would be the unique integers left in the array. However, let's just say instead of taking out 3, so instead of taking out 3, let me just this. Okay, yeah, so instead of taking out 3, how about if we take out the number 4 and the number 2? You see right here we have 2 unique integers left. So 2 is less than what we did previously of taking out the 3, which resulted in 3 integers left. So like we said, we wanted the least number. So we would want this result of 2 instead of 3. So for this problem, what we're going to want to do is we're going to want to create a hash map, which is going to basically get our occurrences. So right here, you see right here for both of these examples, I put the integers and how many times they occurred in the array. So 5 occurred twice and 4 occurred once. In this case, 3 occurred 3 times and so on. And the reason why we want this is because we are going to be using a priority queue for this problem. And we're going to be using a priority queue because we want to take out the least the integers that happen the least number of times, because doing this, what's going to be left is the integers that occur the most number of times, which is going to allow us to find the least number of unique integers. So in this case, we took out the 2 and the 4. We see that 3 and 1 occurred the most times, so those are going to be the unique integers after. So let me just start with the process of how we're going to do this. So we have our k, which represents how many integers we could take out. So let's start here. Our k is 1. Well, we could take out 1. So we're going to subtract the occurrence of the number 4, which is 1. So we're going to be left with a 0. K is 0. We cannot take out any more integers. So if we take out the 4, we're going to see that just the number 5 is left. So in the case of our priority queue, well, there's only just one integer in our priority queue. So our size of our priority queue is going to be 1. So we just return 1, which is going to be the priority queue size. And you see that that works out evenly. But let's see another example where it doesn't work out evenly. So let's say in in this problem, this example number 2. So we are given a k of number 3. And remember that a priority queue has the so it goes from min to max. So these minimum values are going to be at the front of the priority queue. So and that's that's exactly what we want. So let's say k is going to be 3. We're going to subtract what's at the front of the priority queue, which is the number 1, which is the occurrence of 4. So we could take that out. So if we take out the number 4, so k is 3 minus 1, which is going to be with the 2. Okay, let's take out the number 2, which is possible because we could take out 2 and in this case 2 happens one time. So let's take out the 2. So our k is going to be 2 minus 1, which is going to be 1. Okay, so you see here, the problem is that we cannot take out the next number 2 because we could only take out one integer. However, the last 2 integers in our priority queue happened two times and 3 times, and we cannot take those out because we can only take out one integer. So that's where we have to stop. But let's just say we do want to try taking out the number 1. So our k is going to be 1 minus the occurrence of the number 1, which is 2. And that's going to result in a negative 1. Okay. You see right here, that was impossible, right? And in this problem, this is going to let us know what's possible and what's not possible. So for example, in the example number 1 that we did earlier, we saw that k ended up evenly at a 0. So we returned its priority queue size, which was just a number 5 in the priority queue, which was represented by the occurrence, which is just 2. So we could just return the priority queue size. But in this case, we want to check if it's less than 0. That's gonna let us know that we took out one too many. So right here, when we took out the number 1, this resulted in a k of negative 1. So that's gonna let us know, hey, we took out one too many. So instead of returning the priority queue size, we're gonna want to return the priority queue size before it was less than 0. So before it was less than 0, before k was less than 0, k was 1. So that was before taking out the 1. So let's just 1, not 2. So our priority queue size, once we took out the number 1, our priority queue size was just 1. But prior, it was 2, size of 2. So that's what we're going to want to return. We're going to want to return, if our k is less than 0, we're going to want to return the priority queue size prior to k being less than 0. So prior to k being less than 0, the priority queue size was 2. So our result is going to be the priority queue dot size plus 1. So that's going to be 2. So our result is going to be 2. So again, when k ended up at 0 evenly, we could just return the priority queue size, which is just 1. However, in example number 2, we see that it didn't end up evenly because right here, when we had in k1, we couldn't take out either of these. However, once we did try to take it out, we saw that it resulted in a k less than 0. And that's saying, hey, we took out one too many. So let me return the size of the priority queue prior to taking that element out. So prior to taking the element out, it was just 3 and 1, which was 2, which is the least number of unique integers that we could that we're gonna have after taking k elements. So let me just go ahead and start with the coding. So as I mentioned earlier, we're gonna use a hash map. be a type integer. And this is going to represent our occurrences of our numbers, and it's going to be new hash map. Okay, and I'm just going to use an enhanced for loop num through array. Now we're going to do occurrences dot put our num, and we're going to use map dot get or default. Put our num 0. We're going to put a default value of 1. So what this is what this for loop is doing is, if the map already contains the number, well, we're just gonna add 1 to the value, and the value is the occurrence. So say 5, okay, if we put it into our map, the default is gonna be 1. We see it again, we're gonna add 1 to its value. So 1 plus 1 would be 2, and so on. So we're gonna do that to get to make the key, which is the integer, and the value, which is the occurrence. Okay, now we're going to use a priority queue. Because we can call it just PQ for priority queue. Or TQ. And we are going to pass the map.values in. Okay, and the map.values was just the values right here. Because if you think about it, the values kind of represent the integers itself. So in this case, let's say right here in this operation, when we took out the 1, then the next one, it was saying we took out the 4, we took out the 2, and then we just had these 2 integers left in our priority queue, which represented the integer 3 and the integer 1, which are the unique integers after removing the k elements. So what we're going to want to do is, while our k is greater than 0, we're going to subtract pq.pull. Okay. So it's this logic that we went through right here. So once we're removing it, we are subtracting k, and we are subtracting k by the occurrence, which is in our priority queue, which we put with map.values. Okay, so now for the return statement, if k is less than 0, we are going to return the pq.size plus 1. So again, like I said earlier, we took out 1 too many, so we're going to return the priority queue size plus 1. Like in this example that we did, when we took out the 1, we saw that it resulted in k being less than 0. So we wanted to return the priority queue size prior to taking the number 1 out. So prior to taking it out, the priority queue size was 2, which just had the 3, which represented the integer 3, and 2, which represented the integer 1. Okay, otherwise, in this case, when it ended evenly, well, we just returned the priority queue size. So if k is less than 0, we're going to return the priority queue size plus 1. Otherwise, we're just going to return the priority queue size. Okay, and that should be it. Let me just run the code to make sure there's no bugs. Oh, I used map, so. Get default. Oh, misspelled it. And you. All right. Again, I use map, but we can fix that. Occurrences dot values. All right, finally. All right, so let me just submit. And yeah, it works out perfectly. Yeah, hopefully I explained it. It makes sense. Well, I explained it to where it makes sense. And if you guys have any questions or yeah, any concerns or yeah, just questions in general, you guys just could leave them in the comment section and I'll answer them.